Morning all. Welcome to the lecture 10 of module 1 in database management system. So in the last video we have discussed the entity. We have started with the entity relationship diagram. In there we have seen what is an entity, how to represent an entity in a ER diagram. Then we talked about attributes and how to represent the attribute in a ER diagram. Then we have seen the different classification of attributes like composite attributes, multi-valued attributes, derived attributes, and so on. Then also we have seen about complex attributes, non-valued attributes, and so on. Okay, so all those things we have discussed. So now all of you are familiar with how to draw an ER diagram that includes entity and set of attributes. Okay, we have also seen we have also discussed how to represent a key domain, a key attribute in an entity. Okay, that also we have seen. Okay, so now today we are going to deal with the continuation of ER diagram. The next concept we are going to see is relationship. Okay, so what do you mean by a relationship? So we know what is an entity. Okay, and each entity will be having attributes. Attribute represent the properties of entity. Okay, all those things we are familiar. Now we can see what is relationship. So relationship is the association among several entities. Okay, so relationship actually tells the connection or the communication between the several entities or association among several entities. Suppose this is a entity set. Employee is an entity type. Department is also an entity type. This E1, E2, E3, E4, E5, E6, E7, etc. is the entities. In the department entity type, D1, D2, D3, etc. are the entities. Okay, so this is employee and the department are the entity types. E1, E2, etc. are the entities. Here D1, D2, D3 are the entities. So here the first E1 is participating in a relation called R1 with the department D1. That is why they have given a connection between E1 and D1 through R1. Okay, so E1 is participating in a relation R1 with the department D1. Okay, so E2 is having a participating in a relation R2 with the D2. E3 is participating in a relation called R3 with the D1. E4 is participating in a relation R4 with the D2. E5 is participating in a relation R5 with the D3 and so on. Okay, so that is why they are saying that relationship is the association among, okay, this is the association among several entities. These are the entities. Okay, this is called the entity type. Okay, so works for is actually the entity, works for is actually the relationship. Okay, name of the relationship. Okay, name of the relationship, or we can also say it is the relationship type. Okay, so this is called a relationship. So relationship is the association among several entities. Okay, now in ER diagram, this relationship, entities and the relationship is actually represented like this. Okay, so relationship is actually represented in diamond structure. Okay, so here employee, this is the first example. Employee is related with the department. Okay, employee entity type is related with the department through the works for relationship. So here the relationship is works for. Okay, that means that employee is working in the department, or the employee is working for the department. Another example is this one, the student entity type. Okay, student entity type and course entity type. So these two entity types are related using the relationship enrolled in, which means that the student is enrolled in course. Okay, a student can be enrolled in a course. Okay, or students are enrolled in courses. Okay, so this is the relationship. This is how two entity types are connected, or two entity types are related. Clear? So this entity, so relationship is the association between two entities. Okay. You can see the term called a relationship type. So we all know that what is a relationship. So relationship is nothing but the association between two entities. For example, here we are having entity E1 and T1. So this R1 is a relationship, okay, that associates E1 and D1. Similarly, R2 is a relationship that associates E2 and D2. Okay, similarly, R3 is the relationship that associates E3 and D1 and so on. Clear? So what do you mean by this association, or what type of association is happening here? Which means that E1 is working for the department D1, E2 is working for department D2, E3 is working for department D1. Okay, so what is the name of the association here? Here the name of the association here is works for. Okay, so the relationship type is the works for. Okay, so R1, R2, R3, etc. up to R7 are the relation. Okay, so these relations are of which type? Which is works for. Okay, so the relationship type is the which means the relationship type which is the associating with the different entities. Okay, relationship which is associating with the different entities. So these are the relationship. So these relationship are associating. What type of association is happening there between these two entities? Okay, that relation is works for. So the relationship type is works for. Okay. Next statement is a relationship set. So what do you mean by a relationship set? So look at here. This is a entity type. Okay, entity type. This is also a entity type, and this is a relationship type. Okay, that we have already seen. So in this entity type, we have entities E1, E2, E3, E4. So these are called entity types or entity set. Entities or entity set. Similarly, D1, D2, D3, etc. are called entities or entity sets. Okay. Similarly, in works for relationship type, this R1, R2, R3, etc. R7 are called the relationship set. Okay. So these relationship sets are of the same type works for. Okay. So R1, R2, R3, etc. up to R7, all these relationships are of the same type works for. Okay. So that is why it is written here. The relationship set is a set of relationships of the same type. Okay. So these are the set of relationships of the same type. Okay, which is the type here? Works for. Okay. Relationship set. Okay. So another example. This is a student entity. Student is the entity type. Marks is the entity, another entity type. S1, S2, S3, S4 are the entities of student entity type. M1, M2, M3, M4 is the entity of this marks entity type, and this is the secured is actually the relationship type. Okay, so relationship type is secured. So here S1 is participating in the relation R1, okay, to connect with the M1, M2 and M3. Okay, so S1 is participating in the relation R1 to connect with the M1, M2 and M3. Clear? So here the relationship type is secured and the relationship sets are this one R1, R2, R3, R4. Okay, so this R1, R2, R3, R4 are of the relationship of the same type. Okay, they are the relationship of the same type. Okay, so R1, R2, R3, R4 are called a relationship set. Okay, now another term is the relationship instance. So in this figure, we are having only S1 is participating in a relation R1. Okay, so no other entities are participating in any of the relationship. Only S1 is participating in the relationship R1. Okay, so the relationship instance is R1. Okay, so R1 is the only relationship instance here. Clear? So we have come across the keywords called a relationship, relationship type and relationship set. Okay. Now degree of relationship type. So degree of a relationship type is the number of participating entity types, which means that how many entity types are trying to get the relationship with each other. Okay, how many entity types are trying to or want to get relationship with each other. Okay, so this is called the participating entity. So here, look at here. So here how many entity types are trying to get a relationship? Here only two entity types are participating, student and marks. Okay, so here two only one and two entity types are trying to get a relationship with the relationship called secured. Okay, so here also there are two, employee and department. These are the two entity types. Okay, they are going to relate with the relationship type called works on. Okay, so degree of the relationship is trying to say that how many entity types are trying to participate in the relationship. Okay, the degree of the relationship type is the number of participating entity types. Okay, the first one is unary relationship, second one binary. Here we are having three types. The first one is unary relationship, next binary and ternary. Okay, so unary, from the name itself we can see that say that unary means only one entity type will be there, will be participating in the relationship. Okay, so look at here, see here only one entity type is here, student. Okay, student is trying to get a relationship, is linking with, it is having a relationship monitor. Okay, so association is maintained within a single entity. Okay, so this student is trying to have a relationship with the student itself. Okay, the student is trying to have a relationship with the student itself through the relationship type monitor. Okay, clear? So this is called unary relationship. Next one is binary relationship. So here the association is maintained within two entities, okay, or two entity types. Okay, so here association is maintained within two entities. So instructor, course. Okay, these are the two entity types. So they are trying to relate each other through a relationship type called teachers. Okay, so instructor teaches courses. Okay, an instructor teaches course. Clear? So this is the binary relationship. It means that there are two entities involved in the relationship, or two entities are trying to participate in the relationship, or association is maintained within two entities or entity types. Okay. Ternary relationship. Here association is maintained with three entities or entity types. Okay. Here there are three entities: part, supplier and project. Okay, so these three entity types are trying to connect each other and they are trying to have a relationship. Okay, their relationship type is supply. Okay, so their relationship type is supply. Okay, so these are the three possible relationships that can occur in a system. That is called the degree of a relationship type. Okay, degree of a relationship type. Clear? So unary, binary and ternary. Now constraints on the binary relationship. Now we are talking about the constraints or the rules or the strictness we are going to, or stringent rules that we are going to apply on the binary relationship. Okay, that is what we are going to discuss. So constraints on a binary relationship. Relationship types have certain constraints that limit the possible combination of entities that may participate in the corresponding relationship set. So this relationship constraints will try to do what? They will try to limit the possible combination of entities. Okay. So in the previous figure we have seen that each entity is trying to participate in a relation with the entities in the next entity type. Okay. So there are restrictions as to how many entities can participate in the next entities of the next entity type. Okay, there can be restrictions. So how these restrictions are done? That is done using two concepts, which are cardinality ratio and participation. Okay, so relationship type have certain constraints that limit the possible combination of entities that may participate in the corresponding relationship set. So we can distinguish the two main types of binary relationship constraints. So what are the relationship constraints that we are going to see? Cardinality ratio and participation. Okay, so today we are going to see this cardinality ratio in detail. It is a very important concept. Okay. So what is cardinality ratio? Cardinality ratio for a binary relationship. So here we are actually specifying the concept of binary relationship, the constraints on the binary relationship. So we are discussing the constraints only on the binary relationship. So in binary relationship, the cardinality ratio specifies the maximum number of relationship instances to which an entity can take part in. Okay, so maximum number of how an entity can in what number an entity can relate with another entity in the entity type. Okay, what is the maximum number of relationship? Okay, what is the maximum number of relationship instances a entity can take part with another entity? Okay, or we can also say that the number of entities to which another entity can be associated through a relationship set. Okay, so these terms will be it will be clear by after the explanation of our examples. Okay, so there are actually four possible cardinality ratios. The first one is 1 to 1, 1 to many, many to 1, and many to many. So let us explain all these concepts in detail: 1 to 1, 1 to many to 1, and many to many. Okay. So before that, one more point is that we can express the cardinality ratio in ER diagram. In ER diagram, we can draw the cardinality ratio by representing this. If we are giving a directed line, which means that it is signifying 1. Okay, undirected lines means it is signifying many relation. Okay, that is directed line satisfies means that we are giving a directed line means that there is only a one association, that is there is having only one association with the other entity, or one relationship with the other entity. So undirected line means there are many association among the entities. Okay, so we can when we explain the example, it will be more clear. So here 1 to 1, first cardinality ratio is 1 to 1. What is 1 to 1 cardinality? An entity A is associated with at most one entity in B, and entity B is associated with at most one entity in A. Okay, which means that, look at this figure. Here manager, okay, a manager manages department. Okay, so this is here. So here the entity type is manager and the department, and the relationship type is managers. Okay, so here it means that each manager is a manager, a single manager can manage a department. Okay, in reverse fan we can in reverse order we can say that a department is managed by a single manager. Okay, that is what it is explained here. And entity A is associated with maximum one entity in B. At most means maximum. And entity A in this one, entity A is associated with maximum one entity in B. Okay. Also the entity in B can have maximum association with an entity in A. Okay, that is what it is saying. Clear? So a single manager can manage a department. A department can have only a single manager. This is called one-to-one relationship. Okay. So when we look at this figure, it will be more clear. Okay, this is another example. A male, a single male is married to a single female. A single female is married to a single male. Okay. So here this is the entity type, this is also another entity type, and these are the entities M1, M2, M3, M4, M5, M6. Okay. Here F1, F2, F3, F4, F5, these are the entities. Okay. So this M1 entity is having relationship with the F1 entity. Okay. So M2 entity is having relationship with the F2, M3 with the F3, M4 with the F4, M5 with F5. Okay. So all these entities are having a single relationship with the other entities in the other entity type. Okay. So this is called one-to-one relationship or one-to-one cardinality. Clear? Next one is another example. Here is a customer can borrow a single loan. This is two entity types, customer and loan. Okay. As I said that a one-to-one cardinality can be represented using directed lines. Okay. So here it is not written 1 1. Either we can write like this, either we can write 1 1. Okay, in this manner we can, without directed lines we can write 1 1 like this, or if we are using directed lines we are not using this label, 1 1 labeling is not required here. Okay. So this when we see this directed line, which means that here the relationship is 1. Okay, the cardinality ratio is 1. Here also it is 1. Here also we can see the directed line, so it is 1 here. Okay. So this means that a customer can have a single loan. Okay, customer can borrow a single loan, or a single loan can be borrowed by a customer. Okay, that is the meaning here. So this is the customer entity type, and this is the loan entity type. The customer entity type is having the following attributes. These are the attributes: customer ID, customer name, customer street and customer city. The loan is having the attributes loan number and the amount. Okay, so this is the relationship type, borrower. Okay, so here the cardinality ratio is 1 to 1. Okay, one here also 1, here also 1. Okay, a customer, which means that a customer can borrow a loan. A single loan can be borrowed by a customer. Okay, that is the meaning here. Okay. Next one is one to many cardinality. Okay, a one to many cardinality. What is one to many cardinality? An entity A, a single entity A is associated with any number of entities in B. Okay, one to many, which means that an entity A can associate with any number of entities in B. Okay. Also entity in B, an entity in B can have only a single entity, at most one entity in A. Okay, I will once more I will say, an entity in A is associated with any number of entities. Okay, that is why it is written n, any number of entities in B. A single entity in B can have one entity in A. Okay, a single entity in B can have association with the one entity in A. Okay, so this is called one to many. So here we have given an example, department and employee. The entity types are department and employee. Okay, or a single, which means, so here the relationship is has. Okay, relationship is has. So which means that a department, it is having one to many relationship, one to many cardinality. Okay, so it means that a single department can have any number of employees. That's right, right? any department, a single department can have any number of employees. Okay, in reverse order we can say that a single employee will be a part of only a single department. Okay, a single employee cannot be a part of many departments. He can be only a part of a single department. Okay, so this cardinality ratio is right. Okay, okay, so this cardinality ratio is logical. Okay, a single department can have any number of employees. A single employee can be a part of only a single department. Okay, so here the relationship type is has. Okay, so such relationship is called one to many cardinality. Okay, so entity A, a single entity A is associated with any number of entities in B. A single entity in B can be associated with only one entity in A. Okay, now in both way we have to represent. Okay, another the same example, it is given the different mapping figure is given here. Okay, so here a department can have many employees, a single employee can be a part of only a single department. Okay, so look here, so here the entities are department type, entity type is having the entities D1, D2, D3, D4, D5. This employee entity type which is having entities E1, E2, E3, E4, E5, E6, E7. Okay, so look at here, here a department, a single department can have many employees. See here, D1 it is connected with employee E1, D1 is connected with employee E2, D1 is also connected with employee E3. Okay, so a single department have many employees. Clear? So similarly D2 is connected with employee E4, D2 is connected with the employee E4. So department D1 is having employees E1, E2, E3. Department D2 is having employees E4 and E5. Okay, D3 is having only single employee E6. Similarly, D4 is also having the single employee E7. Okay, so here we can see that a single department can have multiple employees. That is what it is written here. A department can have multiple employees. Okay, so look at here. Here we have signed directed lines. So directed lines means that it is having only one relationship is one. Okay, no directed lines means it signifies many. Okay, so a directed line means signifies one, a non-directed line or a undirected line signifies many. Okay, so it is one to many relationship. Clear? So a department can have many employees, and each employee, look at here in reverse order, each employee will be a part of only a single department. Okay, so each employee, so E1, so E1 is a part of department D1, E2 is also the part of D1, E3 is the part of D1. Okay, so E1 is not present in many departments, he is only present in a department D1. E1 is not present in D2, D3, D4, D5, he is only present in D1. Okay, so all these employees are present only in a single department, they are not available in many departments. Okay, so this is the cardinality ratio 1 to many. This is another example. Look at here. Here they have given directed line which signifies one. Okay, undirected line signifies many. So this is the cardinality ratio is 1 to many. Okay, this is 1 to many. Okay, so 1 to many we will write 1 and m here. Okay, if you are not providing this directed lines or undirected lines, we will be writing 1 and m here. Okay, not m, m here. Okay. So in this figure it says that a single customer can be associated, can borrow multiple loans. Okay, or a single a customer is associated with several loans through borrower. A customer can associate several loans through the relationship borrower. Okay, or we can also say that a single customer can borrow several loans. Okay, in the reverse fashion, we can say that a single loan, a loan is borrowed by only a single customer. Okay, so this is the concept. This is another example. Manager manages projects. Okay, here the cardinality ratio is 1 to many. Okay, 1 to many. Clear? So here, which means that it is also labeled 1 and m, and also given the directed lines. Okay, so directed lines mean signifies 1, and undirected line signifies many. Okay, so this is 1 to many cardinality. So look at this mapping diagram. So here the entities are M1, M2, M3, M4. Here the entities are P1, P2, etc. up to P7. Okay, so here M1, manager M1 manages project P1, manager M2, manager M1 also manages the project P2, the manager M2 also manages the project P3, which means that a single manager can manage 3 different projects P1, P2 and P3. Okay, this manager M2 can manage projects P4 and P5. Okay, in the reverse fashion, we can say that a single project is managed by only a single manager. Is it right? Yes, a single project is managed only by a single manager. For example, P1 is managed only by the manager M1. The P1 is not managed by M2, M3 or M4. The P1 is managed only by M1. Okay, similarly P4 is managed only by M2, not by M1, M3 or M4. Okay, so this is called 1 to many cardinality. Next is many to one cardinality, the reverse way. Okay, which means that an entity in A is associated with the an entity in A is associated with a single entity in B. Okay, then in reverse way we can say that a single entity in B can associate it with any number of entities in A. Okay, so a single entity in A, we can associate with only a single entity in B. A single entity in B can associate with any number of entities in B. That is called many to one. Clear? So an entity in A is associated with at most maximum one entity in B, and entity in B can associate with any number of entities in A. Clear? So this is called many to one cardinality. Clear? This is another example. So employee works for department, which means that a single employee can works only in a single department. A single department can have many employees. A single employee works for many departments. A single department can have many employees. Okay, look at this mapping figure. The employee E1, these are the entities. These are the entities, and these are the entities here. Okay, so the employee E1 is working in department D1. Employee E2 is working in D1. Employee E3 is working in D1. Okay, so here a single employee is working in a single department. Okay, a single employee is not working in any other department. E1 is working only in D1. He is not working in D2, D3 or D4. Okay, but in reverse way, a department can have many employees. So D1 can have employees like E1, E2, E3. Okay, so D1 is having employees like E1, E2, E3. D2 is having employees like E4 and E5. Okay, so this is called many to one cardinality. Okay, so this is the same borrower example. So here it is many. This does not have any. This is undirected line, so this signifies many. This is directed line, so the signifies one. So many to one. Okay, which means that a customer can have only single loan. Okay, in reverse way we can say that a loan can be taken by many customers. Okay, a loan can be taken by many customer. Clear? So in many to one relationship, a loan is associated with several customer. A loan is associated with several customers. Okay, through the relationship type borrower. Okay. Next is many to many. What is many to many? An entity A is associated with any number of entities in B. An entity in B is associated with any number of entities in A. Okay, an entity in A is associated with any number of entities in B. An entity in B is associated with any number of entities in A. Okay, that is why it is given many to many. Okay, so many to many we will not write M and M. Okay, here we will be given M and here we will be giving N. Okay, many to many. Even though we are writing many to many, the first label will be giving M and the second label will be giving us N. Okay, so which this means that a employee works for many projects. Okay, in reverse way we can say that a project is worked by many employees. Okay, both way we can say, both are correct. Clear? This is another example. A teacher has many students. Okay, a student is taught by many teachers. Both are correct. Okay, a teacher teaches many students, or teacher has many students. A student will be taught by many teachers. So here the teacher 1, these are the entities, T1, T2, T3 are the entities, S1 up to S6 are the students. Okay, so the teacher T1 teaches student S1, S2 and S3. Similarly, the student S1 is taught by teachers T1, T2, T3. So both are correct. Clear? So similarly T2, the teacher T2 taught the students S1, S4 and S5. Okay, clear? Now the students S1 is taught by the teachers T1, T2, T3. Okay, so both are correct. So this is called many to many cardinality. Okay, so these are very important concepts. Please memorize these concepts. So today we have just learned about the cardinality ratio, that is the constraints on the binary relationship type. So there are two constraints, basically there are two constraints, cardinality ratio and the participation. Today we have learned only about the cardinality ratio. The main cardinality ratios are 1 to 1, 1 to many, many to 1 and many to many. Okay, so these are the constraints that we are actually imposing on a relationship. Okay.